Yes, over the last few years, Lonza has really been focused on improving its expression tools for the manufacturing of bispecific antibodies. These range from improved set of expression vectors, the use of our hyperactive piggyback transposase technology, and other vector optimization strategies that go hand in hand to drive up high titers of bispecific antibodies. One area that we hadn't focused on before was in the actual product quality attributes, and that's where bYlok comes in. When you manufacture a standard IgG-like bispecific antibody, there are a number of challenges that can reduce your final product titer and complicate downstream processes. These are primarily the heavy chain heterodimerization challenge, where you can produce heavy chain homodimers versus the desired heterodimer, and you can also have similar challenges with shuffling of the heavy light chain pairs. Now, to solve the heavy chain heterodimerization challenge, the gold standard technology in that space is really the knobs into hole developed by Genentech, and that works fantastically well. But even with that technology, you can still get shuffling of the heavy light chain pairs. Lonza have solved that using their bYlok technology, and it's a very simple platform where we simply engineer 4 amino acids in the antibody focused on one Fab arm side of the IgG-like structure. And what we do is we remove the existing disulfide bond in the constant region, and we relocate it to the interface of the VH and the VL domain on one Fab arm side of the antibody. This disulfide bridge helps to do two things. It helps to drive correct heavy light chain pairing and also prevent mispairing. And in our testing, we see very high rates of full product assembly, typically above 95%, when we combine this new bYlok technology platform in combination with knob-in-hole. So with bYlok technology, we use it to express classic IgG-like bispecific antibodies, and these are those that have 2 different heavy chains and 2 different light chains. The way we use bYlok technology is we use knob-in-hole to solve the heavy chain pairing challenge, and then on one Fab arm side of the antibody, we use the bYlok technology to fix the heavy light chain pairs. Yeah, so when we're using the bYlok expression technology applied to a standard IgG-like bispecific antibody, we will typically go through an initial upfront screening phase. And there what we will do is we will screen the combination of bYlok with knob-into-hole for the candidate molecule and find the optimal combination of those two technologies in terms of the alignment of bYlok with either knob heavy chain or hole heavy chain, for example. Once we've identified the optimal format of the scaffold, we then take that through the rest of the development process, and we typically treat a bYlok molecule exactly as we would any other bispecific antibody once we've reached that stage. The expression vectors are the same, the host cell line and all the downstream processes are the same, and because bYlok represents only a very minimal modification to the natural antibody design, it's only 4 amino acid substitutions, these molecules are considered to fit with all our other platform processes, going all the way through purification, for example. So in that sense, the technology really helps development because it helps to de-risk the expression of these molecules by giving you higher rates of full product assembly, typically identified when we do our lead clone selection process. Yeah, so it's very easy to access the bYlok technology platform from Lonza. It's available as a standalone license, or you can access it as part of the wider GS Gene Expression System toolbox. Customers who access bYlok get access to the protocol required to use the technology, but handily we also offer customers an online portal, and this portal is very easy to use, and you simply put in your antibody sequence, your heavy and light chains. It recognizes if we're talking about kappa, lambda, IgG 1, 2, 3 or 4, and it introduces the appropriate bYlok mutations and gives you back the sequence in a ready to use format, so you can move straight to gene synthesis, vector construction, and then continue through the rest of the development process. So you can access the bYlok technology through our Lonza in Your Lab initiative, and that's where we make available to our license holders all the same expression tools that we use internally at Lonza for our license holders to use in their own facilities. One of the great advantages of that at Lonza is that we can support customers in using their technology because all the same tools that our customers are using in their own facilities are the same ones we're using in-house. And that gives our customers access to our global SME network, so we can ensure you get the best use out of the platform. In terms of bYlok, you can use it in your own facilities, of course, but if you want Lonza to screen your molecules and find the best format of bYlok for your specific bispecific antibody, we can also offer you that service through our early development services team who can do that upfront screening and help to de-risk that expression platform for you.